Hello, it's Mr. Smith again. We're going to do another rate times time equals distance problem. This is video 2. So some of the details we might not go as far. Of course, you can always go back to video 1 to see a little more detail on how to fill out the table. So I'm going to read through the problem and we'll go to get started. So in this problem we have Raven, who left Greensboro with a speed of 56 miles per hour. So I'm going to go ahead and put down some of this information as we go. And so she's leaving Greensboro and she is going 56 miles per hour. And we get that from our first sentence. As we continue to read, it says Starfire, and so this is Starfire, also left at the same time in the opposite direction at a speed of 75 miles per hour. So Starfire is going this way at 75 miles per hour. And it says find how many hours Starfire must travel before they are 225 miles apart. So when we look at this problem, not to spend too much time on the details of what's going on, we have Raven going this way, we have Starfire going this way. So as Raven goes this way, she's covering distance, and as Starfire goes this way, she's covering distance. And we're trying to figure out, when we have this distance and Raven's distance, when will that total distance be equal to 225 miles? So before we get to this part, I just want to like for everybody to have a general understanding of what we're trying to figure out. But let's go and set up our rate times time equals distance table. So we have our rate times our time is going to be equal to our distance. So while I'm writing this table, I want you to think about what two things that we're thinking about, because whenever we're filling out the rate times time equals distance table, we always have two individuals or two objects, two things that we are comparing. So hopefully everybody thought of Raven and Starfire. So we know Raven's rate is 56. I'm going to write her rate. That's kind of a given. And our other person is, that is correct, Starfire. And what is Starfire's rate? That is correct, 75. So we can see it both here in our diagram. We can also see it in our word problem. Now our time, we know that they both left at the same time. So it's going to be the same for both of them. So I'm going to put X, because we don't know what that is yet. So I'm going to put X for both. So we have X for Raven and we have X for Starfire. And the way we find distance is always going to be the same. So the way we fill out this table, we're going to pretty much, if we have rate and we have time, we're just going to multiply them together. So 56 times X is 56X. So put 56X. And for Starfire, we do the same thing. 75 times X is 75X. So that means if they both traveled for an hour, it would be 56 times 1, which means Raven traveled for a distance of 56 miles. If they both traveled for 2 hours, then we'll plug in 2 for X. So if we were trying to figure out how long Starfire ran, we'd do 75 times 2, which is 150 miles. So I'm going to write the distance underneath each one. So we said Starfire's distance is going to be 75X, and then we know Raven's distance is going to be 56X. So we know when we take our two distances, what do they need to add up to? 225. That is correct. So when we add Starfire's distance, which is this part, and when we add Raven's distance, we know it needs to be equal to 225. So we're going to add 56x plus 75x is going to be equal to 225. And so now we just solve our equation. So we're going to combine our like terms. 56x plus 75x. We have our x, we have a 1, carry that, we get 131 is equal to 225. And then what do we do here? We just divide, because we have 131 times x to the inverse. And we x is equal to, and we're going to divide this. I'm going to show you all longhand division because I know a lot of you like to try and skip out. Let me slide this up so y'all can see what's going on. So 131, we have 225. It can go into there only one time. So we have 131. We subtract 4, borrow 12, 9. Bring down 0. So I'm going to add it up, so let's try 8. And so we have 8, we have 3 times 8, it's 24, 8, so that's too big, so it's probably going to be 7. So let's do 131 times 7, 21, 9, 17. So we know it's 7, so we have 9, 17. We subtract that, that becomes a 3, 10, 3, and we get 230. That's probably the last time I do it. So let's go with 1.71. So we know 1.71. Is that our answer? No, because we always want to write a complete statement. So what we're trying to do, we're trying to find how many hours Starfire must travel. So we look at Starfire and we look at her time because we're trying to find out how many hours. We know X is the only thing that is a measure of, or excuse me, time is the only thing that is a measure of hours. So we know our answer is going to be our X value. So I'm going to draw a little arrow so we can see what's going on. So I'm going to take my X and pull it along over here. And we know Starfire must travel 1.71 hours before they are 225 miles apart. Circle that bad boy. And we go back and find how many hours Starfire must travel before they are 225 miles apart. Look, my answer, Starfire must travel 1.71 hours before they are 225 miles apart. Makes perfect sense. So again, I hope this helped. If you have any questions, you can always replay the video or you can go back to video 1.